Okay, so now we'll start with activity 2.5. So first question says, on an average 240 ambulances arrive in a hospital per hour. Okay, assuming that the number of ambulances arriving in the hospital follows Poisson distribution, find the probability that one ambulance will arrive 30 second will arrive in a 30-second time interval. Answer the in two decimal points. Okay. Uh, so just by looking at this, we can say that this is a they have already mentioned that this is a Poisson distribution. So in Poisson distribution, it is crucial to see the lambda value, right? So the lambda value will be given in terms of uh, number per time interval, right? Or we can say average per time interval. Okay, so here the average time interval that they have given is 240 per hour, right? So that they are asking us to find out in 30-second time interval. So here this time interval is different than the time interval that they have defined for lambda. So the now we have to convert this lambda value to the required time interval, right? So just by simple cross multiplication we can do that. For 3600 seconds we have 240 ambulances. For 30 seconds we have 30 into 240 divided by 3600, right? So this equals to 2. So we can say that lambda is equal to 2. Now what is the value of k now? So k is how many ambulances that we are expecting to arrive, that the probability we have to find out, right? So they are expecting one ambulance, so the k value will be equal to 1. So Poisson distribution for uh, f of x, so here x is the number of ambulances, k is given as 1, is given by e to the power minus lambda into lambda power k divided by k factorial, right? So here e to the power minus 2 into lambda, that is lambda is 2, 2 to the power k is 1 divided by 1 factorial. So this is equal to 0.27. So moving on. So the average number of penalties charged by a police in a day for not following traffic rules is 5. Assume that the number of penalties charged in on different days are independent and the number follows a Poisson distribution. Find the probabilities that less than 4 will be charged in a day. Okay, so here the interval that they have asked us to find the probability and the average is same, so there is no need to convert the lambda value, right? So the lambda that they have given is average per time interval is 5 per day, right? So that is 5. So now they are asking us to find out the probability that less than 4 is 1, 2 and 3. So k value takes these three. So now we have to find out uh, probability of, let's say, f of x of k less than 4. So now this is given as f of x of k equal to 1 plus f of x of k equal to 2 and f of x of k equals 3. So now this is e to the power minus 5 into 5 to the power 1 divided by 1 factorial plus e to the power minus 5 into 5 square divided by 2 factorial plus e to the power minus 5 of 5 cube divided by 3 factorial. So now we can take e to the power minus 5 as common. So we'll have 5 plus 25 by 2 plus 125 by 6. So now if we simplify this, we'll have 0.26 as the answer. Next one, the number of items sold on an online store in an hour follows a Poisson distribution with lambda equal to 2. So the lambda is 2 per hour. Okay, find the probability that in the next 4 hours exactly 3 items will be sold. So now they have given us k as 3, and the time interval that they're asking us to find out is 4 hours. So we need to convert lambda, right? For 1 hour it is 2, for 4 hours it will be 2 into 4 is lambda will be given as 8 per time interval, right? Okay, so now the new lambda is 8. Okay, so now k we know, lambda also we know, we can directly apply the formula of f of x of k equals 3 is given by e to the power minus 8 into 8 to the power 3 divided by 3 factorial. So now this is equal to 0.029. Next one, the number of emails received by a person follows a Poisson distribution with a mean of 6 email per 2 hours. What is the probability that the person will receive 5 emails over a period of 2 hours? Again, the time interval for the average and the required probability is same. So there is no required to convert this lambda. So now directly we can substitute the values, that is lambda is given as 6 and k is given as 5. So the Poisson probability will be f of x of k equal to 5 is nothing but e to the power minus 6 into 6 to the power 5 divided by 5 factorial. So now this is equal, now this will be equal to 0.15. Moving on to activity 2.6, we have first question. Let x be a discrete random variable with a probability mass function given in the table. Define a new random variable y is as x plus 1 whole square. The range of y. So they are asking us to find out the range of y. So now directly we can say for x we have minus 2, minus 1, 0, 1 and 2. So now y is equal to x plus 1 whole square. So now we have minus 2 plus 1 minus 1 square is 1. Again minus 1 plus 1 is 0, 0 square is 0. 0 plus 1 is 1, 1 square is 1. Again 1 plus 1 is 2, 2 square is 4. 1 plus, 2 plus 3, 2 plus 1 is 3, 3 square is 9. So the range of y is equal to 0, 1, 4 and 9. So option 3. Next one, geometric variable, random variable with probability of success as 0.8. We have a function of f of x. So that is it is x square for x less than 5 and it is 25 for x greater than or equal to 5. Now they are asking us to find the range of f of x. Okay, so now if we substitute, let's say x as 1, 2, 3, 4, 5 and 6, right, and so on. Okay, so now what will be f of x? F of x will be 1 square. It is less than 5, so 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25 and 6. Now 6 is greater than 5, so the answer will be 25, 25 and so on, right? So what will be the range of x now? So the range will be 1, 4, 9, 16, 25. Okay, this one is the answer. Next one, suppose we have a uniform distribution with these as the samples, with this as a sample space. Now they have defined f of x as x square. Now we have to find the probability of f of x equal to 4. Okay, so firstly I'll write the variable, random variable x. X takes the value minus 3, minus 2, minus 1, 0, 1, 2 and 3. So f of x is nothing but x square, right? So that is x square. X square is 3 square is, okay, before that I'll write the probability of probability of x, that is p of x is nothing but, so we have 1 2 3 4 5 6 7 total outcomes, okay, out of which each probability, since they have given uniform, so the probability will be likely, right? So we have 1 out of 7, 1 out of 7, 1 by 7, 1 by 7, 1 by 7, 1 by 7, and 1 by 7. So now let's calculate x square. So that is minus 3 square is 9, minus 2 square is 4, minus 1 square is 1, 0 square is 0, 1 square 1, 2 square 2, sorry, 2 square 4, 3 square is 9. So now again then we have a repetitions, right? So now what will be p of f of x equal to, let's say, 0, right? So we have only one outcome, so the probability will be 1 by 7. So what will be p of f of x equal to, so we have required to find 4, right? So then we have two entries for 4, so we have to add both of them. I can either get this or either get this. So for our condition it is always addition, right? 1 by 7 plus 1 by 7, that will be 2 by 7. This is the answer.